Mabel TA Exam Review Unit 3, question number 13. Solve the following independent system of equations. So this was kind of nice. They told us it's independent, so we are looking for a solution where these two intersect. We have a couple of different ways of doing that. We could try and graph it. If you have graph paper and you feel you can be very accurate with that, you could go ahead and do that by solving both of these for y. Then you have it in slope-intercept form, and you could graph it that way. I like algebraically because I know for a fact that it's going to be intersecting at that point because I've proven it with the algebra. And so I also taught in one of my videos how to do the elimination method. That is not required, but sometimes it can be pretty fast. I'm going to go ahead and do the substitution method, which was discussed in your textbook. And then those of you who might want to stick around and see the elimination method, I think I'll do that second. So the first thing I want to do is take one of these equations and solve it for x or y. And because this one is smaller, it'll be really fast. So I'm going to just take this guy here and pick a variable. And since x is right here, let's just solve it for x just because we can. So I'm going to add 5y to both sides. So add 5y here, add 5y here, and I'm left with, on the left-hand side, 7x equals 5y. And then to continue solving for x, I need to divide both sides by 7, so x is all by itself. Oops. There we go. Sorry about that. Divide by 7 and divide by 7. There we go. So on the left-hand side, 7 divided by 7 is 1, so that leaves me with x, and that means x equals 5 over 7y. And I'm going to take this and then substitute it into the other equation. Make sure that you don't substitute it back into the same equation you've just solved for, or you're going to get like y equals y, x equals x. Now that's okay if you are using the other equation. If you get a true solution using both equations, like 0 equals 0 or 1 equals 1, then that just means you have a dependent system. If you put it back into the same equation, you will get, without a doubt, like 0 equals 0 or 7 equals 7 or 5y equals 5y, because you've just used the same equation twice. And if it were the same equation, it would be dependent, but I have this other equation that I need to worry about. So I'm going to copy and paste it down here. And every time I see that x, I'm going to substitute this 5/7 y. And we will be dealing with fractions. So I'm going to put parentheses in here and copy and paste that in. Okay, so now I have 4 times 5/7 y. And I can do 4 over 1. So that it makes it a fraction, and I do numerator times numerator and denominator times denominator. So this gives me 20 over 7 times y minus 8y equals negative 36. Now to combine the y's, I can, some of you might feel more comfortable changing that to a decimal, and then continuing on to solve for y. I'm going to leave mine in fraction form and just find a common denominator. So I'm going to copy this for my next step so that I can stay consistent here, and paste, and then find a denominator. Since 8 does not have a denominator, I can put it over a 1, and then the common denominator would be the lowest common multiple between 7 and 1, which is 7. So I'm going to multiply the top and bottom here by 7. So we'll take this, again, copy and paste it here. 7 times 8 is 56, and 7 times 1 is 7, so it's 56 sevenths. So I have 20 sevenths minus 56 sevenths, y on there, equals negative 36. So 20 minus 56, gives me negative 36, right? So I get negative 36 sevenths y equals negative 36. Okay, so now I need to divide by this fraction of negative 36 sevenths, but we don't divide fractions, we multiply by the reciprocal, or we'll end up with a complex fraction. which just means we end up with fractions inside the fraction. So I'm going to multiply both sides by this reciprocal. So multiply by negative, oh, I guess I should do that on the next step. So we'll copy and paste this down and multiply both sides by negative 7 over 36. And you can see if I do it on this side that the 7s will cancel because I have one on top and one on bottom, and the 36 will cancel, one on top, one on bottom, or you can think 36 divided by 36 and 7 divided by 7, so I'm left with y. And I'm going to just copy and paste this over here. I'm going to multiply this by negative 736. Now on the left-hand side, I end up with 1. 1 times y is y. And on the right-hand side, I actually end up with negative 36 divided by a negative 36, or a negative times a negative is positive, so I can ignore the negatives now. And 36 divided by 36 is 1, and 1 times 7 is 7. So I get y equals 7. And now, because I have this here solved for x, I can bring it down and substitute this in for y. So I have a 7 here, and get my parentheses around that. 7, I end up with 7 on the top in the numerator and 1 on the bottom. So 7 divided by 7 is 1. 1 times 5 is 5. So I get x equals 5. And I have the solution 5, 7. And I can do that over here. Now if you wanted to go ahead and do the decimals, that would probably have sped us up a little bit. You wouldn't have had to find the common denominator. And I'm going to leave that up to you, but I'm going to leave the fractions in just in case somebody needs help with the fractions. So I have 5 and 7. Okay, the other method we discussed was the elimination method. So those of you who are going to continue in this video, I'm going to show how to do the elimination method. Sometimes it's faster, especially if we have a quick way of getting from one to the other. This one doesn't, so I'd actually have to multiply both equations by something, and it'll still work. Let's see, so I would multiply either this top one by 7 and the bottom one by 4, so I end up with 28 in front of both of these. So when I add or subtract, so one of them I would pick to be a negative and then add them together and it'll cancel it out. But then I would do all those terms. Or I can eliminate the y by multiplying this by a 5 and this by a negative 8, or this by a negative 5 and that by a positive 8, so that one of them is negative, and when we add it, it'll cancel out. It doesn't matter which one I pick, so I'm going to go ahead and do the 4 and 7 just because it'll be, since they're up at the beginning. So I'm going to specify this by showing, I'm going to multiply this entire equation by 7. And the bottom, I need to multiply this entire thing by 4, and I need to pick one of those to be negative. And it doesn't matter, so I'm going to pick this one because that's where my cursor is. Okay, so then I multiply it into every single term here, and I end up with a positive 28x, and then multiplying that 7 over into the 8, I get negative or minus 56y equals, and I don't have 7 and 36 memorized, so 36 times 7 on my calculator gives me 252, and that was negative. I apologize. We have a negative there. Okay, so the next one, negative 4 times positive 7x gives me negative 28x, and that's good because when I add these together, these will cancel out. Now negative 4 times negative 5 gives me positive 20y, and anything times 0 is still 0, so that one is still 0. Now adding these equations together, these cancel out because positive 28 minus 28 is 0. And then I have negative 56 plus 20y, and adding those together gives me negative 36y, and you'll say, hey, that number looks familiar, equals 252, and then you just divide by negative 36. So 252 divided by 36 gives me positive 7 on my calculator because I'm just not bringing up Excel right here, right now. Dividing those both by negative 36 gives me y equals positive 7. And then we go up into one of these equations. Now, the disadvantage to this is that you're going to have to solve one of those because in the elimination method, or the substitution method, we already solved. So you'll have to go through plugging that in and solving for it. So I'm going to pick the smaller one just because it'll be faster. And then we substitute what we got in, or plug in the 7 for y. And so 5 times 7 is 35. And so I have 7x minus 35 equals 0. To solve for x, I need to add 35 to both sides. So add 35, and I end up with 7x equals positive 35, and then divide both sides by 7. So I copy and paste that here, and divide by 7, and divide by 7, which gives me 7 divided by 7 is 1, which times x is x, and 35 divided by 7 is 5. So either way, either method that you prefer, so I still end up with 5 and 7. And we'll move to the next one.